September 2025. We may have uncovered a tantalizing clue pointing toward a true second Earth. And astonishingly, it lies just 40 light-years away. After 4 detailed transit observations with the James Webb Space Telescope, JWST, scientists have identified this world as the most promising candidate in our galaxy for hosting life. If the next 15 transit observations confirm its habitability, this planet could become one of the most favorable locations for discovering life beyond Earth. Hello, Earthlings. I'm Jonathan Pierce, and over the next 20 minutes, I will guide you on an extraordinary journey to this planet, explaining the groundbreaking discoveries and unraveling the secrets that may reveal whether life exists elsewhere in the universe. Just 40 light-years away, in the constellation Aquarius, lies a mini solar system that defies everything we thought we knew about planetary systems. Orbiting a faint red dwarf star, barely visible to the naked eye, are 7 rocky planets, each roughly the size of Earth. This faint star is called TRAPPIST-1, and your main focus is TRAPPIST-1e. So, what makes the TRAPPIST-1 system so extraordinary? Let's start with the basics. The central star, TRAPPIST-1, is an ultra-small red dwarf, only slightly larger than Jupiter, yet emitting a mere 1/1800th of the Sun's brightness. To visualize this, imagine holding a tiny candle and trying to match the brightness of a stadium floodlight. It's an almost absurd difference. Yet, from this faint glimmer, a cosmic miracle emerges. 7 rocky planets, each comparable in size to Earth. Before this discovery, Earth-like planets were scattered and rare. But here, we see a cluster of 7 terrestrial worlds, a planetary arrangement never before observed. You might wonder, if the star was discovered in 1999, why were its planets only confirmed in 2017? The answer lies with the TRAPPIST telescopes, 2 optical robotic telescopes, twins in name and function. TRAPPIST North in Morocco's Atlas Mountains and TRAPPIST South in the Chilean Andes tirelessly monitored the star, eventually revealing this cosmic treasure. The method they used is called transit photometry. In simple terms, scientists watch for tiny dips in starlight as planets pass, or transit, in front of their host star. When a planet crosses the star, it blocks a minuscule fraction of the star's light. By detecting these subtle changes, astronomers can determine the planet's size, orbit, and even some hints about its atmosphere. Initially, only the 3 innermost planets were discovered. Later, data from the Spitzer Space Telescope confirmed all 7 planets, all rocky rather than gas giants like Jupiter. This is crucial, because rocky surfaces are essential for life as we know it. Here's another remarkable point. Because TRAPPIST-1 is so dim, its planets must orbit extremely close to receive enough heat to sustain liquid water. Their orbital radius is only 1/13th the distance from Mercury to the Sun. To put that in perspective, Mercury, the closest planet to our Sun, is 13 times farther than TRAPPIST-1e is from its star. Being so close also means the planets are likely tidally locked, just like our Moon. One side always faces the star, basking in perpetual daylight, while the other side remains in eternal night. Imagine standing on TRAPPIST-1e, right along the twilight zone where day meets night. To your left, a red-orange sun that never sets, painting the sky in eternal sunset, with temperatures just right. To your right, the cold, dark expanse of space, filled with countless stars, yet freezing. This extreme contrast creates a cosmic visual feast, unlike anything on Earth. Even more intriguing is the planet's location in the habitable zone, the region where temperatures could allow liquid water to exist. TRAPPIST-1e receives about 2/3 the stellar energy Earth receives from the Sun, meaning its surface temperature could be remarkably similar to Earth's, neither too hot nor too cold. This is why scientists are so focused on this planet. With the right atmosphere, TRAPPIST-1e could be tailor-made for life. But before we get too excited, there's a major caveat. Being this close to its star is both an advantage and a potential hazard. To truly confirm habitability, we must determine if the planet has an atmosphere and what gases it contains. The James Webb Space Telescope tackles this using transmission spectroscopy. Simply put, when the planet transits in front of the star, some starlight passes through its atmosphere. Gases like oxygen, carbon dioxide, and methane absorb specific wavelengths of light, leaving distinct fingerprints. JWST's NIRSPEC instrument, nicknamed EarthBag, detects these absorption lines, revealing the composition of the planet's atmosphere. TRAPPIST-1e is ideal for JWST studies. Because the star is so dim, the drop in light caused by the planet is far more noticeable, like blocking a candle in a dark room rather than the sun in the sky. Previous observations of TRAPPIST-1c and 1d suggest little to no atmosphere, but TRAPPIST-1e shows clear spectral signals, indicating it likely does have an atmosphere. A team called DREAMS dedicated all their JWST observing time to this planet, conducting 4 separate transit observations. The first time in history such detailed atmospheric data has been obtained for an Earth-size exoplanet. At 40 light-years, about 37.8 trillion kilometers, we are able to analyze starlight to decode the atmosphere of another world. Truly a technological marvel. Preliminary findings have already ruled out extreme possibilities. TRAPPIST-1e has no primordial hydrogen or helium atmosphere. These would have long been stripped away. It doesn't resemble Venus, with a thick carbon dioxide atmosphere, nor Mars, with a thin, almost negligible atmosphere. Currently, 2 possibilities remain, both crucial for assessing habitability. 1. An Earth-like atmosphere. If confirmed to be mainly nitrogen, 78%, with oxygen, 21%, and small amounts of water vapor, carbon dioxide, and methane, with surface pressures similar to Earth, TRAPPIST-1e could truly be Earth 2.0. Despite tidal locking, atmospheric circulation could balance temperatures between the day and night sides. Greenhouse gases would maintain surface temperatures between 0 degrees Celsius and 100 degrees Celsius, enabling stable liquid water and oceans, potentially supporting life similar to Earth's. A frozen planet with an anti-greenhouse effect. High methane levels could block near-infrared radiation, causing surface temperatures to plummet. The day side might support a small ocean, while the night side freezes solid. Even in this extreme scenario, twilight zones could harbor microbial life. Some scientists even speculate it might be an icy volcanic world, with frozen surfaces but internal tidal heating sustaining subsurface oceans, similar to Europa or Enceladus in our solar system. 4. Of course, the less exciting possibility remains. TRAPPIST-1e could be a bare rocky world, with the spectral signal coming from surface reflection rather than an atmosphere. So, what is the truth? In the coming months, 15 additional transit observations will focus on detecting carbon dioxide and oxygen. Carbon dioxide would confirm a secondary atmosphere. Oxygen could hint at biological activity. These observations are expected to conclude by December 2025. Looking further ahead, NASA plans to launch the LifeWorld Observatory Telescope around 2040, designed specifically to search for extraterrestrial life. With capabilities surpassing JWST, it may directly image TRAPPIST-1e, revealing oceans, clouds, and possibly signs of life itself. Regardless of whether TRAPPIST-1e becomes a second Earth, its existence is nothing short of a cosmic miracle. Just 40 light-years away, it is essentially our cosmic neighbor. In September, scientists also discovered geological structures on Mars that could be linked to life, suggesting that life may not be exclusive to Earth, but potentially common in the universe. Could TRAPPIST-1e be the first planet where we detect life? Will its atmosphere reveal signs of living organisms? Share your predictions and observations in the comments. Let's see how close our guesses come when new discoveries unfold. Next, let's appreciate the beautiful universe.